So that being said, after filtering, now I have to extract this order revenue, and it is of type float, and hence we need to typecast as well. We not only have to extract but also typecast it to float, otherwise it will be treated as strings only, and using strings we will not be able to add. When we use plus, it will actually concatenate. For that purpose, we have to perform row level transformation to extract this order item revenue, and then typecast it to float. And the way it will be done is by using dot. You can actually create multiple variables and take care of this. However, I will be using only one variable, order revenue, and then I will be performing all the operations and get the final output to order revenue. And then we can actually say map. And when it comes to map also, it takes, you can see the syntax here. It says f colon string implies b, which means map takes one argument, and again it is of type anonymous function or function, and that function takes one argument which is of type string and returns something. Depending upon what transformation we are trying to do, the data type will vary. So in this case we will be returning float, in some cases we will be returning string, so on and so forth. So here again I'm saying y implies y dot split, comma is the delimiter, and then we have to get the fifth element, and hence we have to say 4, which will give us the order item subtotal. As it is of type float, we have to say 2 float here. So now this function which we have passed to map is processing each string in the iterator and returning a float value. You can actually validate by rerunning this program once again. Now you can see this order revenue contain 3 values, and each of them are of type float. If you want to validate the data type, you can actually expand this bulb and then click on add type annotation, and you can see that it is iterator of float. Okay. However, I want to invoke reduce function. As reduce function returns something else, we just have to remove the data type and then say dot. And then when it comes to reduce, let us see the syntax. You can see the syntax on the top. The size of the screen is not big, but it actually gives us what type of function it takes as an argument. So the function that we need to pass as part of reduce takes 2 arguments. You can see a1 comma a1 implies a1, and it is in the circular bracket. So we have to specify something like this. So let's say x comma y, or let's say x comma y, and then as part of the functionality we want to add these 2 values. I will explain why we have to use this logic once I test it, and then you will be able to understand. So typically as part of aggregation, what we'll be doing is we will be providing the functionality about what we should do with these 2 variables. In this case, we are trying to add the values. That's why it is specified like this. Why we are doing this, I will explain in a moment. Now, if you actually look at the return type of this entire logic, it is of type float, because we are adding 3 float values and we are getting total of them, which is again a float. And on float, you cannot use for each. Rather than specifying like this, you can just say println order revenue. Okay, and then you can actually run this. Now you can see the total revenue for order ID 2. If you want to get the order revenue for order ID 4, you just have to go to run, edit configurations. You can actually pass 4 here, and then apply, and then okay. And then you have to right click and run order revenue. You cannot pass directly while running using IDE. However, from command line we should be able to do so. So now let us understand how reduce works. So before getting into this reduce, we see 3 values, right? Let's assume that they are nothing but v1, v2 and v3. So if you actually look at the source code of the reduce function, it actually have the aggregator like total, and then as part of the for loop, it will get the current record and the next record. So in the first iteration, it will get v1 and v2, and we are using those things as part of this function. So as it gets v1 and v2, we are trying to get total of those 2 values, and x plus y will get that value. And as part of the second iteration, whatever is the total of the first 2 values will be first argument, which is nothing but x, and the next value will be the y. So every time we are just adding the aggregator which we are getting in each iteration with the next value in the loop. Once everything is saturated, it will actually return the total. So it actually look like this. So I'm actually writing pseudocode here. So if you want to write your custom reduce function, it will be like this: def my reduce. Okay, and typically your reduce function takes a collection, not individual records. So here also we are invoking this reduce on collection, right? So instead of using object oriented notation, I'm using regular function notation. So typically this my reduce will take a collection. Let's say the collection name is C, and also it will take a lambda function, and that lambda function takes 2 arguments. Okay, so this is our function specification of reduce, and as part of this we actually create a variable like this where total equal to 0, and then we actually loop through the collection. So in this case, C is collection. So actually what we can do is total can be the first element of the collection. We can initialize to first element of the collection. Now from second element of the collection, we can actually iterate the data. There is a function called tail, and we can actually get the subset of that collection. So let's assume that we are iterating through this collection of all elements except first, because first is already assigned to total. Okay, so now I will be the value from the collection in each iteration. So as part of the first iteration, we will get the C of 1. As part of the second iteration, we will be getting C of 2, so on and so forth. Now here you can say total plus equal to whatever function we are trying to invoke, and then total comma I. Okay, so here in the first iteration, it will give the first element in the collection, which is assigned to total. That will be the value that will be passed here, and the I, which is being read starting from the second element in the collection, will be second argument. Okay, so now we have to pass whatever we want to do with those values as logic when we invoke this myReduce function, and that's what we are doing here. We are trying to just add those two values. Okay, and then finally you just return the total, and that's it. Okay, so when it comes to the reduce function, it gives us the functionality of initializing the totaler and then looping through those things and invoking the function and also returning the totaler or aggregator. Okay, you don't need to come up with that logic. You just have to focus on what you should do with the aggregator and the element which you are passing as part of each iteration when this reduce function is executed. So as part of the reduce function, you will have this for loop internal if you look at the source code. Okay, so this is what is happening here. Again, if you actually go through our Scala fundamentals, which we have provided as reference material, we have covered how to develop custom mymap, myfilter, myReduce functions. If you want to understand more about these intricacies, if you want to practice, you can fall back on that material and you can take it from there. Okay, that being said, I'm deleting this and our function is ready. We are done with the development to get the order revenue for a given order ID in our order items dataset. And typically once the development is done and once it is validated using IDE, we have to run it as a jar file. So to run it as a jar file, first you need to compile this program into the jar file. Whenever we make changes to the code and whenever we save the code in IDE, as part of this Scala demo, there will be a subdirectory called target, and as part of the target, you will see a subdirectory called Scala-2.11. It is based upon the Scala version which we are using to develop our program or application. And if you look into this, there is a classes directory. So if you actually say find classes and hit enter, you can see several classes here. It is nothing but the bytecode which can be executed as part of the JVM. Now to execute as bytecode as part of the JVM, we have to compile these classes into a jar file. And the way you can compile into a jar file is by using SBT. So you can just say SBT package and hit enter. And you have to be in the project base directory to run this SBT package. There is a way to achieve this using IntelliJ also. You don't need to come to command prompt and do this. However, you should be familiar to take care of this using command prompt as well. Okay, especially on Windows, as we will be developing using IntelliJ running on Windows, and typically validation will be done on Ubuntu, because there are two different environments which we are using when it comes to Windows. Instead of using IntelliJ directly to compile into jar file, it's better to get used to this command prompt approach. I typically recommend people to either use Mac or Linux for the development, but unfortunately most of the enterprises are typically on Windows, and hence we need to work around some of the challenges which we encounter using Windows as development environment, and this is one of the workaround. I figured it out. Okay, so that being said, now we can use SBT run. If there is only one main function, it will be automatically invoked. However, the function is taking arguments. So if I just run SBT run, it doesn't know what should be passed as arguments, and hence it will fail. If there are no arguments, if there is only one main function, it will be executed automatically for you. But our program takes arguments. That's why it is complaining with Java lang array index out of bounds exception. So to fix this, you can actually say SBT run main, and you have to specify the program name. You have to specify fully qualified class name here. So it is nothing but order revenue. Typically, it is the object which we have created as entry point for the application, as it takes an argument of order, actually two arguments of the path of the files and the order ID. We have to pass those also here. So the first argument is path of the file, which is nothing but mntc data retail db order items part hyphen 5 zeros, and then order ID, which is nothing but 2, and hit enter. Now it will execute the jar file and give us the revenue for the already which we have passed. Okay. So once you have this jar file, you can even use Java -cp command also, but you need to figure out how to pass the class name and how to pass the arguments and all those things. I will be covering those things at a later point in time. Typically, we will not be deploying the code using SPT. Typically, we'll be using Java, or if it is Spark-based applications, we use Spark submit command to deploy the applications. Okay. So this is how you can develop, validate on your PC, and then build a jar file. You can validate jar file also. Once it is ready, you will be deploying it in the production. So depending upon the type of application, we'll be deploying in a different way. If it is a web application using Play, you have to deploy it in Tomcat or some other application server. If it is a data processing application, if it is using Spark-based APIs, we have to deploy it using Spark Submit by using enterprise scheduler tools or open source scheduler tools. So that is about the complete development life cycle. If you guys have any questions, let me know. Otherwise, we'll wrap up for today.